So I record my lecture, okay? Sometimes I post on the YouTube, you can watch it later. I probably will do that. So this is a section 6.4. Now, what are we going to do? We're going to continue study the logarithm function. I begin with the definition. We know that we have a e to the x, right? Y good. So you solve for x, and you introduce the notation, okay? Those two are equivalent. There's no difference. Then you get, you change the variable. Because the tradition in the new function, the input variable will be x, so you get natural log x. Okay. So my question is, we know that, right? The derivative of e to the x is e to the x. This is the only function we have. Its derivative itself. Okay. So my question is, what is derivative of natural log x? Okay. So how do we find it? We can find it using the derivative of e to the x. Okay. So this is what we do. Now we remember we have this, right? Right. So this is a x is greater than 0. Okay, x is always greater than 0 because natural log x e to the x they are inverse to each other. That's why you have this idea. So let's differentiate both sides with respect to x. Okay, so derivative of e to the natural log x, okay, by the chain rule is going to be the derivative of e, right, to some variable, and the derivative of natural. This is where we get the derivative of natural log x. Okay. Okay, on the right hand side is just 1 because the derivative of x is going to be 1, right? All right. So we get the derivative because what is this part? This part can be replaced by x. Okay, so you get natural log x is just 1 over x. Right? You solve for the derivative. Wow. So this is it's interesting. This natural log x is defined only for x, for positive x. Okay, it's a very interesting formula. All right, what we can get, what we can see from here. Okay, remember, recall that if you find the antiderivative in calculus 1, right? You know that this is going to be n plus 1 over x to the, right? But this is true for what? For n plus 1 is not equal to 0. If, okay, so that means if n is not going to be negative 1. So we did not actually get, so then what happens to this one? Right? We cannot use above formula. Right? Now you know what happened, right? This is going to be 1 over x dx, but the antiderivative 1 over x is natural log x. Now we can say this is going to be natural log x plus 1. Okay? But this still, be careful, this is true for x positive, okay? Then, but the x to the negative 1 can be defined for negative x. Right? So can we just state the formula without the mention x greater than 0? Right, because natural log of x is only defined for positive x. Okay, for positive x, yes, the integral of x to the negative 1 is going to be natural log x plus c. If x is negative, this is not defined. The right-hand side is not defined. Okay, so we have to do something to get a general formula. Okay, so now absolute value x is going to be x if x is positive, negative x if x is negative. Why negative x? Negative x is not necessarily be negative value. If x is negative, so the negative sign is invisible. In order to drop the invisible negative sign, I just put a negative sign in front of that. That's the only way we can do in mathematics, okay? So negative, negative become positive, so negative sign will be killed, okay? All right, so let's try to find the derivative of absolute value x for x not equal to 0, because anyway, when x equals 0, it's not defined. Okay. Well, let's find out. Okay. If for x positive, we already know that the derivative is going to be natural log of x, right? So it's going to be the derivative is going to be 1 of x. We already know that. No problem. For x negative, for negative x. Okay. So if x is negative, I know this is going to be natural log of negative x, but this is still defined because negative x is a part is going to be negative. Negative x is positive, so it's defined. Now, when you differentiate this, you have to use a chain rule to define, right? Whatever inside the natural log, it will go to the denominator, right? Then you have to differentiate negative x. And negative x is going to be 1. Negative 1, right? So you still get the 1 of x, but this time it's negative, okay? But you get the same formula. No matter what is x is positive or negative, the answer is always 1 of x. So we can combine them. Then we say for x not equal to 0, you always get this formula. Okay, that is good. Okay. So now we have, if x is not specified, could be negative value, then you can always get this formula. Okay, for this x, of course, cannot be 0. Because when x equals 0, the left-hand side is not defined, the right-hand side is not defined, so we don't care. Right? We just, but x could be negative, so we get, we get this formula, right? So when you differentiate, let's see, when differentiate something like that, right? Use a chain rule. Y is not x. Okay, by the chain rule, y is something depends x. Then first of all, you put the 1 over y there, then dy. That's the chain rule, okay? By the chain rule. Okay, by the chain rule. Yeah, how about the integral, evaluate the integral of 2x plus 1 dx. Okay. The only formula I can use this, okay? Even this one looks similar to that, 1 over x something, because this is 1 over 2x plus 1. So you cannot apply that formula, above formula directly. You have to change the variable in the denominator. So it's 2x plus 1. Okay, let u to be 2x plus 1. Then the du equals 2 dx. Okay. So that implies dx is going to be half of du. So the parameter is very important. So don't, when you write the integral, some students get used to not to write dx, but this is very important part of the integrals. So the integral become this is 1 over u, right? But dx is half of du. Then you can about using about formula, right? Half of, right? So this part you can use the formula. Only after you simplify to this level, you can apply the above formula. Okay, so this is going to be half of natural log of absolute u plus constant. Okay, then you replace u by 2x plus 1. Now, you cannot remove the absolute symbol because 2x plus 1 could be negative. Okay. So if we do have, I do see some students, whatever you see 1 over something, they just like this. Yeah, this is natural log of y plus c. But if I change dy to dx, this is not going to be, it's not going to be that. Okay, you are not, in general, you cannot evaluate it until you you modify the function. Sometimes you can, sometimes you cannot. Okay, so be careful about this. So when you write an integral, okay, do not miss any parts of that. Okay, that play very important role. It's not like a necessary item for fun, you know. This is a part of the integral, just like a derivative. You have to tell, you know, sometimes you will use a y prime if it's clear. But if it's not clear the variable, which variable you're talking about, then you have to use a dy over dx. Okay. Okay. So let's do the next problem. The integral of x over x squared plus 1 dx. Okay. So here we use a substitution. Let u to be x squared plus 1. Right. Then du is going to be 2x, the derivative of x squared plus 1 dx. So this part, x dx, is going to be still going to be half of du. Okay. Okay, so the integral is going to be, here's u, and x times dx is going to be half of du. So it's, you end up with the same integral. You will get you have to simplify to the final version, you know, 1 over u du. Then you can apply the above formula. So that will be natural log of absolute over x squared plus 1. But you know that x squared plus 1 has never been negative. So it's not necessary to put the absolute value there. Okay, so it's just, that's enough. Okay. All right, so let's go back to, we're going to go back to natural logarithm. Okay. We know that for the general one, right? This is going to be natural log of x, natural log of a, right? Over natural log of a. So if you know how to find the derivative of natural log of x, then you can find the derivative of natural log of, you find the derivative of x with base a. Log of x with base a. So the derivative, okay? So the derivative here right now, it's constant, right? Taken out, and you differentiate the natural log of x, which is what? Which is 1 of x, right? So you will get, right? Because this part is going to be 1 of x. Right, this is a 1 of x. Yeah, it's a quite you know, natural log of x shows up naturally, right? Remember, yeah, if you have a derivative a to the x, right? You have a to the x, you also get a natural log right here, right? This is the nature of this name. Yeah, so the nature log Km's nature is that's what I call nature log. Okay. Even you begin with a general log function with base a. After you differentiate, you get 1 of x times natural log a. We do not define the derivative. We find it. It's now it's there. You know, we do not, mathematicians do not create the formulas. We just discover the formulas. Just like a physicist, we don't create the laws, right? Naturally, like a Newton's law. Newton just discovered that. The same, yeah. Okay. Of course, we have to. Sometimes we have to create the symbols to describe it. Okay. Like a natural log, I use ln. You know, you can use different letters, right? If you know how to program it, you always create any, you know, any combination of letters will be available for that. I remember when I was trying to read the C class language book, so it's self-study. I just, the first page is about variables. I remember. Yeah. I already forgot this. It's a program. It's very interesting. Yeah, just for fun. I bought a book for Java program. That was 2000, almost 20 years ago. Yeah, that time, the very popular C++, Java. I'm not sure what's going on right now, but this is probably the same kind of language. Yeah. So a to the x, right? So you compare that, the natural log appears naturally in both areas. All right, so I'm going to focus on derivatives. We're going to find the derivatives of a more complicated. Yeah, let's use a natural log again. So this is going to be x squared, square x squared plus 1, right? Find the derivative with respect to x. Okay. Now, what is the best way to find the derivative? Well, you can say I'm going to use a chain rule, and I will show you one way to do it. But that's not. I'm not going to stop there because it's kind of difficult to do that. You see, look at the derivative, right? Then derivative of the natural log of x squared. Right? Then you will see that okay, this is something inside the natural log that will be go to the denominator. Then you differentiate. Then you have to differentiate this the square root of x squared plus 1. I don't think this is the best way to solve the problem. You should modify the function so that you can easily find the derivative. Okay, this is still correct way to do that. Correct. That's not the best way to do it. Okay, so we will try different ways. So when I see this, right, I can use the formula for log functions. I can change the square root to to this. Heck, if it's inside natural log, it's, the derivative of square root of x squared is difficult because it's a square root of radicals, right? If it's just x squared plus 1, that's easy to find the derivative, just 2x. So now, if I change the function to this form, then be easier. Okay. So I can easily define the derivative. I take a constant out. Okay, so you will get, so whatever inside of the natural log will go to the denominator. I still have to differentiate x squared plus 1. That's easy, just get 2x. Right? So you get 2x. Okay, after you simplify, you get x over x squared plus 1. Okay, that's easy. Now, if you want to continue work on the first one, yes, after you simplify, you still get x over x squared plus 1. But it takes more time. It's much easier to make mistakes. If I give a problem on the quiz or test, if you think you need more space to finish that, maybe more likely this is not correct. It's incorrect way to do that because its problem is designed. I did that, I need sometimes a little bit crowded, but usually it's enough space if you put the key ideas there. Okay. Okay. So the next problem, y equals natural log of x plus 1 over x minus 1. Find the derivative of y with respect to x. It's quotient of two functions. So you look at this function. If you find the derivative directly without modifying the function, you have to deal with the derivative of the fractions. I don't like the, I don't want to use the quotient rule to find the derivative. It's too much work. Okay, if possible, don't try. Avoid using quotient rules to find the derivatives. So I needed to modify. It's going to be x plus 1 natural log of x minus 1, right? That's the good part of the natural log. Okay? Then it's easy to find the derivative of each term because x plus 1 is not a fraction, right? So dy over dx is going to be the derivative of the first one minus the derivative of the second one. So I get 1 over 1 plus 1, because the derivative of x plus 1 is 1. So minus this. Cool. So you don't need to even simplify it. If you want, you can, you can, right? It's going to be x plus 1, x minus 1, x minus 1, minus x plus 1. Right? So that is going to be negative 2, x plus 1. Okay? So for practice, I wanted to find the derivative of x squared plus 1 to the power, to the fourth power. Find the derivative with respect to x. Right. Okay, so x squared plus 1 to the fourth power. You don't need to multiply this out. And this is the whole part, right? I think it's you have to change it to this function, right? Then it's easy to find the derivative. Okay, so you can quickly write like a 4, then x squared plus 1, then x squared plus 1 power. Right. Use this notation. So you will get 4 x squared plus 1 is 2x, and then express as x, 8x over x squared plus 1. And most of the time we will deal with natural log because we know that the general log function with base a is always can be written as natural log x over natural log a. That's just constant time that. No big deal, right? So if you if you are given y equals log with base 2, right? And yeah, if you ask it to find 8 to the power x, right? And find the derivative of this. There are a couple ways to do. One is you maybe simplify the function first. Yeah, find the y prime. Okay. You can simplify. This is so you should simplify the function first. This is going to be x squared, right? But this number is just 3. Then it's very simple when you if we simplify it, just just dy dx is just 6x. Okay. Yeah. How about we can also apply natural log functions to find the derivative of some complicated functions. Okay. For example, like y equals square over x squared plus x over x squared minus 1. Find the derivative of y with respect to x. Oh, this is complicated, right? Yeah. What is the best way to solve the problem? Right? You have to apply the chain rule. You have to use a quotient, quotient rule to find the derivative of the quotient. That takes too much time. So what I'm going to do is I'm going to use natural log to change it. Okay. So I put the natural log on both sides. Okay. Then I can modify this. It's going to be 1/2. Right? Then you will continue. You will get half natural log of x squared plus x minus natural log of x squared. So now it's lined up. Good. Although you have more terms, but they're staying online instead of stackable, stacked together. Much easier to handle. Okay. So natural log of y equal this. I differentiate both sides with respect to y, with respect to x. Okay. Then you can get this with respect to x. Okay. Then the other side will be, first of all, you get this, right? Then you differentiate x squared plus x with 2x plus 1. Then minus this, and you get 2x. And okay. Then how about the right-hand side? Well, left-hand side is just equal to, right, 1 over y and dy over dx. That's what I want to find out, right? Right. So dy over dx is going to be half of y. You multiply both sides by y, and you get 2x. I think this is much easier. Now, what is y? Y is already given. Okay, all you have to just replace y by the y. What is y? Y is going to be natural log. No natural log. Y is just the square root. Y is the square root of x squared plus x over x squared minus 1. So this is a y. Okay. And here is 2x plus 1, x squared plus x minus 2x, x squared minus 1. So we find the derivative. Okay. Let's go back to the idea. Let's go back to the original problem. Okay. So I'm given the function y equals square root of x squared plus x over x squared minus. I want to find the derivative. I don't want to use the quotient rule to find it. So I put a natural log on both sides. All right, and that's simplifying the right-hand side and make them line up, right? The left-hand side is also not that difficult, just natural log of y. So when I differentiate with respect to x, by the channel, the left-hand side is going to be 1 over y times the derivative. That's what I want, derivative. The right-hand side, it's easy to find the derivative. So I get 2 terms. Then I find the derivative and multiply by both sides by y. But I know y is already given. Y is this square root of x squared plus x of x squared minus 1. So that is the way to find the derivative. Okay? And that's probably the quick way to do. All right, so y equals find the derivative with respect to x. So please do this problem. right, so let's do this problem, and the best way to do is to put the natural log on both sides. Okay, then this is 1/3, so you can take it out. And then you also can line up. Okay. So this is the natural log of y, right? Now when you then you differentiate both sides. It's like implicit differentiation. Okay, if you differentiate both sides, you get this. And here, the derivative is going to be just 1 over x minus 1. And here's 1 over x plus 1. Okay. Now if you combine, if you can combine them, right? If you combine them, you get x minus 1, x plus 1. And I think it's going to be x plus 1 minus x minus 1. So you get 2 in the numerator. Right? But you're looking for the derivative y with respect to x. So you can get 2y, 3x minus 1, x plus 1. But what is y? Y is already given. Okay? Y is going to be the third root of x minus 1 over x plus 1. So it's going to be the third root. So I can get x minus 1, x plus 1, the third root of that. All right, so I can simplify it because they are yeah, we have to simplify it, right? So you have x minus 1 to the 1/3, you have x minus 1 in the denominator. I think you can get 1 minus 1/3 is 2/3. And x plus 1 is 1 plus 1/3 is 4/3. Okay, that should be the answer. Okay. Yes. No, this problem is okay. Yeah. But honestly, you always see the common term, the x minus 1, x minus 1. You really should put them together as one term. You can put in the numerator, put denominator, doesn't matter. But don't write actually x minus 1 place, x and another place. Yeah, they should be combined. That's general common sense, yeah. This is a minor problem, okay? So as you see that when we study calculus, right? We constantly improve our algebra skills. Okay, if you make mistakes, you learn. Oh, you will learn more stuff to improve it. So gradually, yeah, after you finish, all the calculus courses, even you got a B in high school in all the math courses average, then if you go back to high school, take a test, probably get A. Okay, yeah, that's the general rule. That's why. It's required, the students who can, if someone who wants to teach in high school, you have to get a bachelor degree in mathematics. Even the students don't always get a B in math courses in high school. They're still qualified to teach those courses because it's improved. Okay. So it's also important to learn how to express the idea step by step. So if there's a mistakes, we're trying to give you more partial credits. But if it's not readable, okay, my handwriting is not perfect, but I still better than some students. Just kidding. Yeah, it's readable. Okay, and when I was grading tests, sometimes it's hard for me to figure out where's their solution. Yeah, because I couldn't find the correct answers, it takes me a longer time to understand. Okay, I know you are under pressure when you take exams, but if you get used to express clearly when you do the homework step by step, then you should be able to express them in the correct order. Right, and do you have any questions about last homework? You know, something maybe I'm doing. I don't have a textbook yet. Anyone who has a textbook, I can look at the problems and answer some questions. Yeah, it's too heavy because today I barely get to the parking lot and couldn't find the parking space. And I didn't have time to go back to the office to get it. I know what the material we covered. I taught for more than 20 years. Thank you. So this is a section 6.4. Okay. By the way, the natural log function and the exponential function is the relationship between them is just chicken and egg. So which one is the first? Okay. If you already know, if in some book that defines the natural log function first, then defines the exponential function as the inverse to the natural log. Okay. So inverse function to the log function. Then you can find let me tell you the relationship. So suppose we already know that natural log function, okay, is going to be the inverse function, you know, x equals a to the y, okay? So if we already know, if we know the natural log of this will be x natural log, okay? I can find the derivative of a to the x. Okay, a to the x natural log a. How? This is just because natural log of a to the x is going to be x, right? So if you already know the formula for the derivative, and you differentiate, okay? So the left-hand side, according to the formula we have, is going to be a to the x natural log of a, right? And then the derivative, just a to the x goes to the denominator, right? Look at this. This is the x, this is x. So this part is going here. Then you have to differentiate a to the x. And the right-hand side is just a derivative of what x, which is what. So that implies this implies it's going to be a to the x natural log. Okay? So some books, I think exponential functions comes out naturally, so defines the exponential function, then defines the log function as the inverse function. In some books, some people decided to use defines the natural log function first. Okay? How do you define, right? Natural log function first. You just define natural log function to be the integral of 1 over t from 1 to x. Okay? And that, then you find all the formulas, and then, the natural log, then you define the exponential function to the inverse function. Okay? So for example, what is the natural log? Let's consider the integral of this function, right? From 1 to x, right? From 1 to x, and according to, this antiderivative is going to be 1 to x. It's going to be natural log of x. So after you define the integral, you can define the natural log function. Okay? Here, I already computed. I assume I already know everything about natural log, then again natural. So in mathematics, you have to begin with something. Okay? So you can begin with natural log. I say I'm going to define natural log x to be the integral of this. Then I derive all the identity formulas. Then I introduce the exponential function. Okay. So it doesn't matter which one's first. We will get all the results. Okay. So I'm going to continue look at some examples in the book. That there is an interesting problem here. Is the y equals x to the x. Find the derivative of x. Derivative of y with respect to x. Okay. Right. So this is going to be. So how do you find the derivative of this? There are a couple ways to do. Okay. You can use an exponential function. You can use a log function. Okay. This is another exponential function, x to the x. This is not power function. Okay. So you can, the formula we have here is going to be, right? We also have the formula x to the n equals n times x minus 1. We cannot use any of these formulas directly. Okay, so I'm going to show you a couple ways to do it. One is I put the natural log on both sides. Then I get x times natural log x. Then I can differentiate both sides with respect to x, right? Right, so this is a product to function, x times natural log x. So when you differentiate, you get 1 over y dy over dx. The other side, I can get x 1 times natural log x plus x times 1 over x, which is natural log x plus 1. So I prefer x first. Okay, 1 first, 1 plus natural log x. All right. So dy over dx is going to be y, 1 plus natural log x. And what is y? Y is already know that, x to the x. Right? So that's the answer. Very quick. Is there any way we can, another way to solve the problem? Yes. We're now going to, okay. So this can be written a slightly different way, but it's essentially the same idea. So e to the natural log of x to the x. Okay. Right? But the x to the x inside the natural log can be written as this. So dy over dx is going to be the derivative of e to the x times natural log x. Right? So that is going to be the function itself times the derivative of x times natural log x. So you end up with the same result. You get the derivative of x is going to be 1. Then the derivative of natural log x is 1 over x. Okay? So that, and then you simplify a little bit, you get same result. And the first part is still x to the x. The second part is this. Okay? Right, so let's take a look at next one. So if x to the y is going to be y to the x, find dy dx. Oops, this is implicit differentiation. So you view y as a function of x. It's implicit differentiation. What is the best way to solve the problem? I think we should put a natural log on both sides. Okay, that helps you a lot. That's y natural log of x equals x natural log of y. Then it's product two functions. When you differentiate, you will get the derivative of y with respect to x. So let's differentiate by product. So it'll be y prime, right, plus y, and the 1 of x. That's left hand side. So right hand side is 1 times natural log of y, and x times 1 of y, y prime. Right, so there are two terms containing y prime. So you move to the one side, so you get the y prime natural log of x minus x of y, y prime. So this is the other side, it's y minus x. Right, so you solve for y prime, then you get the derivative. Now, the question is, should we simplify a little bit? I think we should, because it's a fractions inside fractions. So it's best way to do is to step by step, right? I'm going to take x out. So x natural log of y minus y. I take y out, and the y natural log of x minus x. Then move y up, x to down, right? Downstairs. So y over x. If you put the primes here, natural log of y minus y, and the y natural x minus x. Okay, so this is a derivative. It's implicit differentiation. So I don't think we are able to express in terms of x, right? So we're not able to solve for it for y in terms of x. Okay, so the next problem, that's problem number, there are all kinds of problems here. Problem number 42, right? We are given the function was the base b and the 3x squared minus 2. So the question is, for what value of b is f prime 1 equals 3? And we're going to determine the value of b so that the derivative of f is going to be 3, right? So you have to find the formula for the derivative, find the derivative first. Remember, what is the derivative, right? The derivative because the derivative natural log, the log function with base b is going to be 1 over x natural log b, right? So this is the formula. Okay, so you use that. So you will get the derivatives. I think it will be 3x squared minus 2 natural log b. But you have to differentiate 3x squared minus 2. So it will be 6x. Okay, can you see that, right? Yeah, this is the derivative. Then you evaluate at 1. You get 6. 3 minus 2 is what? Natural log of b. That's the value. And this is supposed to be equal 3. Right? Then from here, you find out natural log of b equals 2. Then how to solve b? You just put an e under that. Right? Then you will get a b. B equals e squared. Okay. Well, I know you're waiting for the quiz, right? Okay, I'll give a quiz on Wednesday. Yeah. I explain to you later. One more problem, let me discuss it. So we have a integral of a natural log of x squared over x dx. Yeah, well, let's do a couple of integrals. I see the problems like that on the final exams even, okay? So when you're given, right now, maybe in this section, it's easy, but if we mix up with other problems, it's pretty challenging. You know, what is the best way to solve the problem, finally, and evaluate this integral? Okay. And later on, you're going to study so-called integration by parts, all kind of things. But for this particular problem, here the most natural idea is use a substitution. Okay. That would be du over 1 over x dx, right? So this part, so the integral becomes it's going to be u squared, but x over dx is just du. Right. So you will get 1/3 u cubed plus c, and then what is u is just natural log of x. Mathematics, you know, for mathematics, I think the only way to learn all those ideas is to do more exercise. That's my only experience. Okay, if the minimum requirement is to finish the homework in time, okay, before the next class, because you will be busy on Fridays, even a weekend. Don't wait until the weekends to do the homework. Okay, number 38. Cosine x 2 plus sine x dx. Okay, let's do this problem, last problem. Okay. So cosine x 2 plus sine x. It's a pretty strange problem, right? It's a function. So you try use substitution. So 2 plus sine x this is in the denominator. So you let u to be 2 plus sine x. Then du equals cosine x dx. That's great. So this is what is in the numerator. So the integral becomes just u and the du. Then the antiderivative will be natural log. But don't forget the absolute value first. Okay, in general, it's okay. But this could be negative, could be positive. But this particular substitution here, 2 plus sine x never be negative. So you should remove the substitute value. Okay.